Hello, good afternoon. Can you guys hear me? Okay, good. So let me. Yeah, please. Take this. Yeah, thank you. So good. Good afternoon, and thanks for joining the event. This is Hamid Jafard, and this series of event I name it SQL Server Optimization. I understand that a lot of people that they are struggling for the database performance issues. So why not? We share it to the community. How to resolve that workload performance issues. This is part one, and perhaps I know the timing is not. It might not be with a good time because a lot of people still working at 3 p.m. Anyhow, the session is start recording, and later on we can share the video with others as well. Please feel free to ask me question during the demonstration if it's needed, or you can raise your question in the chat box, then I can attend and answer to your questions as well. Let's check the audio and the visual check. Are you guys able to hear me? If you can, you just raise a hand in Microsoft Teams, so I will notice that. Okay. And are you guys able to see my screen as well? Because I already shared the screen. Okay. And perhaps you can tell me how's my voice quality. Is that okay, or is having some lagging and some problem with my voice quality? So everything looks fine. Okay, great. Let's continue. We are together for another about 2 hours to 3 hours. I just said it 3 hours for this event. This is Hamid Jafard. I'm the technical sales director. You can find me in LinkedIn. I'm the MVP, MCSM holder, and MCM holder for SQL Server, and working in PAR Technology Corp based in Vancouver, BC. Let's see. The first topic is the SQL query performance tuning. So as I said, this is the series of events, and I think within 5 series, it will have 5 parts. So this is the part 1, which is more on identifying and investigating the performance issues, and we find the bottleneck. And the rest of the part, like part 2, 3, 4, 5, is more on how to resolve the performance issues in depth, which means that we will go in depth in the indexing, query tuning, statistics objects, how to configure the SQL instance, and so on. We will go through that. It will be very deep technical sessions in futures and today as well. When it comes to the database performance tuning, I understand it's very challenging because performance issues can happen from any part of the system. It can be from application side, it can be from networking, it can be from hardware configuration. It can be due to the hardware itself, it might be faulty as well. It might be the database design or the queries as well, or even instance configuration. So it can be anything. So how to identify which part is the bottleneck? Today we are going to look into it. When we talk about the performance tuning, it has a process. I'm sure that you try to do the tuning, but you are not sure where to start. Is it from the changing the configuration? Is it trying to create the indexes? What is it? What's the first step? Basically, the first step is very important step. One is the identifying the issue, identifying the bottleneck. Because once you understand what is the bottleneck in your system and what is causing the performance issue, that's the key. Because from there, you are able to plan for the troubleshooting. Once you identify the bottleneck, it can be the query, it can be the hardware, it can be the disk performance, it can be the memory capacity, it can be the CPU specification and the performance. Once you identify that, you need to come out with the troubleshooting. And when it comes to this phase, you need to have multiple and as many as possible resolutions. For example, if it's related to the disk performance, then you need to come out with resolutions like, okay, can I change the disk configuration? Can I, do the index defragmentation? Can I strip the database files into multiple disks? Um, can we optimize the queries to reduce the disk utilization? Can we increase the memory capacity or the instance configuration? Can we change it to use more memory to reduce the disk I/O activities? So all these resolutions, it needs to be listed on, and you guys need to prioritize it based on the effort. Why am I saying based on the effort? Because when it comes to the database performance tuning, basically every departments they are engaged. It's not only the IT department, it's not only the DBA. Because DBA by themselves, they are able to do some measuring from the database perspective, whether the performance increased or reduced, or what's the impact, negative or positive impacts. But when it comes to the business users that they are complaining, they are the people that they are complaining about the performance. Um, they need to measure it as well, which means that you as a DBA need to work with the business users, with the IT team, which it can be the hardware team, network team, and you need to deal with your application vendor. If it's in-house application, then you need to deal with the project team and the developers. So it's not one person's work, is actually involve entire department. So when it comes to the troubleshooting, as I said, you need to prioritize it. Which one has more impact, positive impact with the less effort? So we go by 80%, 80-20 rule. Means that we take care of 20% of the issues that it can resolve 80% of our problem. So that's the point. So once you have those troubleshootings list and I mean the resolutions, then you prioritize it. Then once you apply the resolutions, you need to measure it. You need to measure, for example, you identified is the disk activity is the bottleneck. Then you come out with your resolutions. You apply the resolution one, for example, stripping the database files into multiple disks. Or is a single DB file, you strip it into 2, 3 files, and you strip it, scattering it within few disks. Then you measure it. Okay, did I reduce the disk pressure? Did I improve that disk I/O activities? Does it impact the performance issues that we initially received the complaint from the users? Maybe the users say that no, it didn't impact at all. But initially we find out, okay, it has some impact, but it's not the major. Um, it didn't really improve much. That's why users, they didn't notice the improvement. So you need to measure it. Then you need to, track all the improvements. And why measuring is important? Because if it has negative impact, not the positive, negative impact, you need to revert whatever you have done. Okay, so this is something that we need to really make sure that every troubleshooting resolution is done one by one and step by step. And every time you try to apply the resolution, you need to measure. Once you measure, you compare the result, then you go for the next step. If the result, it shows that negative impact, you need to revert it back. So it's everything is step by step. Why we do that? The reason is we don't want to apply a lot of resolutions. Either it improve or not. At the end, we are not sure whether what has impacted. Okay. Sorry. Okay. Sorry about the call. I just okay. So that's the problem that a lot of DBAs they have. They apply a lot of resolutions. At the end, they don't know what happened. Which part of it actually improved the performance? That's the one. Second, as I said, you need to prioritize your resolution and you need to check based on the impact and the effort, which I put it here, performance versus price. For example, the business users are complaining and say that, oh, we generate a report, it takes 30 seconds, which we have here. And for example, their business tolerance is about 10 seconds. Then you guys need to come into it as a DBA and ask the business users, is it acceptable 10 seconds for
Hi, sorry, you're muted.
okay, the button was.
Yeah,
So when I
maybe
say that,
30 seconds.
oh, it was only 30 seconds.
30 seconds, I would say, yeah.
Yeah, sorry about that. Okay, it was a sec. Um, so basically after the phone call, it happens. So what I was saying, when it comes to the troubleshooting and the resolution, it needs to be step by step, and we should not do it all in one shot because we want to know what we have done and what step is improving the performance. And if the step doesn't improve the performance, we revert back. That's very important things. A lot of DBAs, they try to, do a lot of changes at the same time. And the next one is performance versus price. Isn't it that I mentioned earlier that you need to prioritize the resolution based on the effort and the potential impact? So when it comes to the performance and the price versus price, you need to know what is the acceptable performance for your business. If let's say business users, they say that I need this report generation or this report to be generated within 1 minute or within 30 seconds or less than that, then you need to ask the management whether it's really needed. Is that, a report that needs to be generated fast as possible, or it's something that is not really needed? It can be generated within 5 minutes as well. Okay, because some of the workloads in the database is not critical. It can take longer time, but it's not critical. And usually it doesn't also cause any blocking or other issues. And another thing is, if the business management, they say, okay, yeah, we need to improve that, then you need to come up with the estimation for the cost. Because if, let's say, you guys need to purchase new hardware, or you need to upgrade the SQL instance to the latest version, or you want to do the re-architecturing for the environment, you want to have read-only replica, you want to have separate servers for the reporting, or let's say for the retrieving the data or data warehousing and so on, then you need to come up with the pricing. Then management will decide, oh, whether it's really worth it or not. So it's the same thing. When it comes to the performance tuning, you need to make sure that the performance tuning, the effort, uh, and the cost and the performance you guys gain, it's really worth it. Like, for example, if we do some indexing and we do instance configuration, probably we can increase the performance by 50-60%. But if the user insists want to have improvement for 90%, you might need to change the architecture. You might need to upgrade it. Then it's the additional cost. And management might say that, oh, 60% is good enough. And we don't need to spend a lot of money on upgrading the environment and increase the performance up to 90%. So this is something you need to make sure at first. After that is the time for the baselining. Any DBA that in any organization needs to do the baselining. This is my previous job too. Almost every week I need to do the baselining for every single instance of I was managing previously. So what happens? We need to baseline to identify the bottlenecks. How are you able to identify the bottlenecks when you don't have baseline? It's very difficult. Like, as I was consultant before, so when my client or the prospect asked me, oh, we have these performance issues, first I asked them, do you have any benchmarking and the baseline? If they say no, which usually they say no, it becomes very difficult for me to find out where is the bottleneck, because we don't have any trend. So I need to do a lot of checking, and at the end is more on guessing based on the experience, that whether it's a disk issue or the memory bottleneck or the query issue and so on. So over the years, it become crystal clear for you guys, if you guys are DBA, that which part will be the bottleneck. But initially it will be problematic for you if you want to identify that. So baselining is good for analyzing the bottleneck. It can allow you to come out with the capacity planning. Like, for example, after 5 years, your organization decide to upgrade the hardware, or they want to move to the cloud. You need to identify what is the capacity planning. They will ask you, hey, how many CPU cores do you think we need for this SQL instance? Or how much memory is really utilizing at the moment, and how much resources we can allocate for this instance? If without baseline and the benchmarking, you have no idea what is the capacity for it. And you are not able to identify again, when is the peak hours of your server and when is the non-peak hour. This is very important. Why is it important? Because if you want to manage a database server and make sure that everything is up and running, you need to know which part of a day the database workload is low and which part of a day is high, which part of a month, which day of a month, end of the month or beginning of the month is having high workloads, or middle of the month. And even for the weekly basis, beginning of the week, your server encountering a lot of workloads, or end of the week. encountering a lot of workloads. And what time to what time? The reason is you are able to dynamically adjust the maintenance time. So what happened, instead of saying that, oh, we only perform the maintenance on Saturday or Sunday, you might find out that, oh, okay, I have some certain hours within a week that I can run some basic maintenance tasks and the routines to improve and keep the performance up and running and the database up and running. So this is very important to have the baseline. And also another thing is to downsizing. A lot of companies, they go for consolidation. Let's say they have 100 instances, then the management say, okay, 100 instances, the licensing is killing us and we need to downsize it. Then the baseline is important because you will know that how much resources are utilized. And how often you need to get the performance baseline is usually I take it weekly basis, twice a week. And some companies, they take it on once a week, or some companies, they take it bi-weekly, and some they take it monthly basis. It depends how critical is the workload and how critical is the database environment. If it's so critical, I suggest twice a week. You just take the baseline, do the health check, and check what's going on within the database server. And what metrics you need to use is I'll tell you during the demonstration what metrics you need to use for the baselining. You can use the Windows Performance Monitor tool. You can use the SQL Trace. You can use the DMVs. You can use the extended events. It's not really needed to purchase a software or a tool to do it for you. You can do it because at the end, those tools, they are using all these features within the SQL and the Windows Server. The next step is where to focus. It's very important. Why? Because you want to get the most performance gain from the less effort. Okay. So when it comes to the most performance gain, at first we look at application layer, but most of the times we are not able to change the application. If let's say the application is designed and developed by third party or is design even in-house, but it requires a lot of challenges and the meetings to go through. And most probably the developers will say that, okay, we keep it in view and we see how it goes, whether we can change the codes or not. Another thing is a database design. Again, the application and the database might be the from the third party solution provider, or it can be the internal um, team that developing the database. Again, it goes through the same process. It takes time to do the improvement and to gain the performance. So I can say the three things that area that you can focus is the SQL Server, which is the configuration, indexing, memory optimization, and so on. Another one is the operating system configurations. And the third one is the hardware configuration. When I say that hardware configuration is more on the disk storage configuration, how much they set for the read, write, cache level, what is the rate level, what kind of disk they use, because a disk they can just easily change it. They remove it, change the disk, then let the RAID system to copy over the data and so on. It has cost, but you know that is a part that we can put some effort. So based on my experience, operating system and the SQL, you can gain reasonable performance improvement. Hardware configuration also you can get reasonable performance improvement, but it involves the hardware team and it involves quite long process because hardware team they usually reluctant to change and they have their own benchmark. They will always say that our disk is working well everything is fine. They can show you the disk I/O millisecond. The disk I/O latency is less than 10 millisecond, but the database performance is low due to the disk bottleneck. Database design and the application layer, it has the most significant performance improvement, but it's very lengthy process and the meetings, and at the end, um, the time that it reached for the improving the performance, maybe they already changed the system due to performance issues. So the focus area, I can say, operating system and the SQL instance. Note that we need to pay attention to the application layer. As I said, it takes time. Look into the physical and the logical database design. Physical design, yes, we can change it, but logical, no. Logical is the database, the tables, um, but the physical is how many database files that is created, how many file groups it has, whether we do the table partitioning, we have proper indexing and so on. Logical is more on the normalization and the table design. And the third one is the query that we can look into it. If it's the stored procedure or the views, it's quite easy for us because we just need to make sure the input, output, and the business logic within the stored procedure or the function, it remain the same, but we just do some query changes to improve the performance. We can do that as well. But if the query is sent from the application layer as they call it ad hoc queries, then in that case, it will be challenging. It will be challenging for you to tune it. Over all these years that I have done the performance tuning consultation for many companies, this is the top performance killers that I identified. First is the poor indexing, because once you create the indexes, proper indexes that it can support the query and the workload, majority of the performance issue will gone, is done. And the second is the inaccurate statistics. Sometimes there's no issue with the indexes, but the statistics are not updated. So you guys need to just update the statistics routinely and it works well. The third one is excessive blocking and deadlocks. But once you encounter excessive blocking and deadlocks, um, you need to check the workload. And once it happens, it's not the performance improvement. Actually, it's more on resolving the issue because application cannot work properly. The business cannot respond to the demand. Like for example, I had one experience with a factory that their ERP encountered blocking and the deadlocks, an entire assembly line of the production line is stopped because every time it encountered the deadlock and the blocking, the machines didn't move because they need to update the records, they need to select the records, and entire production line stop. So that is, I can say, it's disaster. It's not performance uh, killer or performance reduction. The fourth one that I realized a lot of those legacy systems they are using is the non-stat based operations. Mostly they use cursor. So that is one of it. Poor query design, poor database design, excessive fragmentation. Excessive fragmentation, it can reduce the performance, but not much. Um, I just want to share with you my experience. Um, I have a client that they are port in Southeast Asia and their workload is huge. And my team was suggesting me that, oh, can we do index defragmentation? And I said, no, this database is very huge. It will take a long time for do the index rebuild and defragmentation. The system is very sensitive and the business is very critical. So instead of doing the index defragmentation, we need to make sure the statistics are up to date. That's all. So once we keep the statistics updated, And we make sure that also the outdated plan caches are removed from the memory. The performance boosts up. We didn't do much things. We just update the statistics and we just remove the non-reusable execution plans, which I call it outdated execution plans. That's all. The client was happy. We didn't request for any downtime or we didn't cause any excessive disk IO, because when you do the index rebuild, it will increase the transaction log file size. It will expand the database file. It will increase the disk IO activities. It has a lot of things, but at the end, after 1 or 2 days, the fragmentations return. So this is something that we don't want to face it. Um, Again, poor execution plans, frequent compilation of execution plan. Yeah, this is one of it, that it kills the performance, but it actually causes the CPU and the processor bottleneck. So if, let's say, your server and your database environment is having sufficient CPU and the processing resources, the compute resources, I don't see that is an issue. But if, let's say, your database environment is having limited processor cores, then yeah, it can be the issue as well. Improper use of cursor. I have seen a lot of stored procedures that they are using dynamic cursor. So it causes the blocking for other users and the other queries. We need to make sure that we use the best type of the cursor for that specific workload. Improper configuration, database log file is growing big, log file is fragmented. Yeah, it can cause the performance issue during the insert, delete, and update activities. And excessive use of improper configuration of tempdb. Yes. If, let's say, the queries are mostly using the tempdb resources, they create temporary table, pump some data, then they try to select, join it. Why not use the CTE? Why do you need to use the temporary table? Or they use a lot of sorting inside the query, which it might not be needed. So sort operation, it will use the tempdb excessively because it needs to keep the result into the tempdb, then it try to read it, then after that sort it and return back to the application or the user. So this is something that we need to take care of it as well. So yeah, this is the top performance killers over the years that I find out. Um, Anyhow, some of them is not the top, but very top is the poor indexing, which you need to take care of it. We go for 5 minutes break, then we come back and continue for the next topic. So the second and the third topic, we will have demonstration as well. Meanwhile, anyone has question, just raise it. Okay. Alona asks, what role in organization should perform this analysis and activities to fix performance? DBA. The DBA is responsible to make sure that we have benchmark for the database performance, database activities, and the workload. We cannot expect hardware team or general IT team, which taking care of networking, application servers, and so on, uh, to implement that or analyze the performance of the database. This needs to be the DBA. Okay, let's start. So if you have no question about the previous topic, the process of the steps, the process, and the resolutions, performance versus price, and the baseline and the benchmarking, then we can proceed with the system performance analysis. The first one was more, the first topic was more on theory and how it needs to be done. Okay, seems that everything is clear, no questions. Good. Second topic, system performance analysis. If you want to analyze or create a baseline for your system performance, I can say that you can use performance monitor tool. You don't need a lot of fancy tools at the moment. You can have performance monitor tool, which I'm going to show you what object, what counter, what instance you need to use to collect the data. And what does it mean? Because you need to understand what that value means to you and what it's representing. Performance monitor tool is the basic tool, but at the same time, it's very informative tool. It can give you a lot of insights. It has few levels. One is the machine, which again, if you have Active Directory uh, credentials, you can access to the remote server from your laptop and select the object and the counter and the instance. Or if you want to run it inside the same server machine, the SQL Server machine, you can just choose the local host, select the object, counter, and the instance. What does mean object? Object means that what sort of performance monitor um, component you want to select. For example, the object we have for physical disk, object we have for logical disk, object we have for network adapters, processor, processes, and so on. We have many objects inside the performance monitor tool. And the next one is the counter. Each object, it has multiple counters. And each counter, it can have multiple instances, which underscore total is one of the instance that every counter has. And number of instances and number of counters, it varies based on the object and based on the counter. So later on, I'm gonna show you how to use this performance monitor to create a baseline. Another one is retrieving performance monitor data by DMV. This is inside the SQL. The previously was more on the server environment. It can be the disk IO, it can be the processor, it can be the memory read and write latencies and so on. But when we talk about the dynamic management views or DMVs, it's something detailed um, in the SQL instance, SQL database engine, which means that every activity that happens within the SQL is actually creating a log, is a kind of diagnostic logs. And from the DMVs, we are able to view all these logs and we are able to analyze it. So the DMVs start based on the category name, like for example, DM underscore OS is the operating system, but this is not the Windows operating system. This is more on SQL operating system because after SQL, in SQL 2005, Microsoft, re-architecture entire uh, Microsoft SQL Server, and they create another abstract layer called SQL OS, which is SQL operating system. That SQL operating system is the abstract layer between the OS and the database engine on top of that. And this SQL OS, it will call the Windows APIs. So as I said, it's the abstract layer. That's why after 1 decade, they came out with the SQL on Linux because it has SQL OS, and the SQL OS now it can call the Linux APIs. So this is the abstract layer. So when it comes to the DM underscore OS, we can get a lot of views, like for example, um, waiting task, wait stats, OS schedulers, OS what I call the memory broker, memory clerks, and so on, all related to the OS and the engine itself. Another one is the DM underscore exec. Exec is a category for execution. So it can be exec sessions, exec connections, exec requests. So it's the view that it will retrieve the data related to the sessions, connections, and the queries. If you want to look at the queries and the sessions, then you need to look into DM underscore exec. If you want to look at the overall SQL database engine performance and you want to find out what's the bottleneck, then you need to look at the DM underscore OS. If you want to look at the blocking transactions that are taking longer time, or you want to look for orphan transaction, the transaction it begin and the session is left open in the sleeping mode, and the transaction is leave open as well and become orphan transaction. Then you can look at the DM underscore trend. If you want to look at the database related information, is the DM underscore DB. If you want to look at for extended events related data, you can look for DM underscore XE. If you want to look at for Azure SQL replication related data, you can look for DM underscore geo or DM underscore database. You can look into the data. I'm gonna show you all these DMVs, and I'm gonna now explain to you what does it mean, and if let's say you want to get um, the blocking sessions, the queries that running, and how much resources used by the specific query, specific users, where you need to look into it. I'm gonna show you during the demonstration. Another thing is when it comes to the um, system performance analysis, and comes to the hardware resource bottleneck, because at the end is more on the resource bottleneck. That's why we try to amend the workload and the queries to reduce the resource pressure. So when you face the performance issues, basically you have resource bottleneck, and that's the hardware resource bottleneck. You have only two options. Either you decrease the request or you increase the resources. Like for example, if let's say you are hosting a database server that it's accepting about 2000 to 4000 batch requests per second, that's quite heavy workload database environment. And you have certain amount of memory inside that server. You have, let's say, 16 cores of CPU, you have SSD, hard disk, and so on. And you encounter the database performance issue. You have two options, as I said. Either you increase the resources, increase the memory, increase the CPU cores, then you resolve the bottleneck. But this resolving, increasing the resources, it doesn't solve the problem permanently. It's just the temporarily, because the workload, the pace is, is high. And again, it will catch up and it will use all the resources. And again, after 6 months, 7 months, 1 year, you might face again hardware resource bottleneck. And the second solution is to decrease the request. But decreasing the request means that you limit your batch request per second, let's say to 2000 instead of 4000, means you are giving a pressure to the business operation. And the users, they need to wait for the resources. That is another issue, which again, at first I said price and the performance comparison, performance versus price. So you need to compare whether you want to increase its additional cost or you want to decrease the request, which is different cost again. Anyhow, there is something in between which we can work uh, to resolve the issue. Slightly decrease the request workload and increase the resources. That's why it comes to the indexing, query tuning, and so on to reduce the workload, and it will release more resources and keep more available resources for extra batch requests per second. We don't increase the resources by physically add on the CPU and the memory capacity, but by reducing and optimizing the workload and the request, we basically try to save a lot of extra resources within the existing hardware. So the bottleneck, it can be in 4 different categories. One is the memory, second is the disk IO, third is the processor, and the fourth is network. And it's already based on the priority and the severity. Usually the memory bottleneck, it can cause CPU and the disk IO bottleneck. I'm gonna show you later on. So when it happens to have memory bottleneck inside the server, usually it will cause the CPU and the disk bottleneck. Why? Because the memory is not sufficient and the CPU needs to read and write from the disk. Then from there, you are engaging the CPU more, and the CPU is going to engage the disk IO more as well. So how to resolve this? To resolve this issue, you need to optimize the application workload. Application workload is your queries. It's good to have indexes, proper indexes. It's good to compress the database if you are using SQL Server Enterprise Edition. It's good to use table partitioning, again, if you are using SQL Server Enterprise Edition. It's good to increase the memory capacity if you are running on virtual machine or it's a physical bare metal server. You increase the main memory. Increasing the main memory or allocating more memories to the SQL process itself, it will load as much as data as possible, and it will reduce the disk activities. Defrag the indexes to make sure we don't have a lot of empty spaces within the data pages. So we utilize the memory capacity as efficient as possible. So this is something that we need to take care of. Memory bottleneck, it can lead to CPU and the disk bottleneck. So if let's say you realize that your database environment is having a lot of CPU spike, let's say suddenly the CPU shoot up to 60, 70%, then drop to 20, 30%, then again shoot up to 70, 80%. At the same time that is spiking, the disk IO also is having a lot of activities and a lot of latency during that time. And you realize that during that time, the memory capacity is already full and it doesn't have any available memory space, then definitely that's the memory bottleneck. So um, once you settle the memory bottleneck, either by creating proper index, compressing database tables and indexes, adding on more memory capacity to the memory modules and the CPU, the SQL process, then you will realize that, okay, memory bottleneck is resolved and the CPU and the disk activities doesn't spike. The next one is the disk bottleneck. When it comes to the disk bottleneck, we don't have memory issues, we don't have CPU issues. But the problem is, what's the symptom? I'm gonna tell you what's the symptom of disk bottleneck. When you restart your SQL service or you restart the entire server or the VM, the warming up period for the SQL Server to load the data and cache data into the memory, it takes longer time. And during that time, you will see a lot of page IO latch shared, which I'm gonna share with you later on. What does it mean, this page IO latch shared? It's a lot. You will see a lot of that during the query execution. You will see the wait stats there. And that represent your disk is slow and is not able to read the data as fast as possible, pass it to the memory for the caching purpose. That's one of it. Second symptom is when you are having a lot of insert, delete, and update workload, because insert, delete, update, once it commit the transaction, it needs to write into the log file. So if you realize that insert, delete, update performance is not as good as select statement, means the disk is having some problem. Again, you might have a lot of indexes. That's why in the insert, delete, and update command is running slow. But if let's say there's a table and a database that doesn't have much of indexes, non-clustered indexes, and not much of columns inside, but it takes a lot of time to insert and commit the transaction, then is a disk issue. You need to always remember that the disk bottleneck, it can lead to the CRUD performance issues. CRUD means that create, retrieve, update, and delete operations and the statements. So how to resolve this disk bottleneck? First, again, optimizing the workload. Maybe you need to rewrite the query to update less records at the same time, to, for example, retrieve less records at the same time. And maybe, you know, try to use less disk IO. The second is you use faster disk. Instead of SAS, you use SSD, you use flash disk, and faster disk that we have in the market. You use RAID array. Instead of using RAID array 0 or 1, maybe you use RAID array 10. That is the fast for read and write. You use SAN system. And when you use the SAN system, you configure it for 70% write cache, 30% read cache. Aligning the disk properly. So when it comes to the disk alignment, the sector, and the track alignment, you align it 64 KB or 4 KB, then it align with the SQL IO activities. You can use the battery backend control cache with some disk, but I think nowadays it's not exist anymore. It's the old technology that it was having a battery, and the disk, uh, it has a battery and it has a cache, because every disk has its own cache. So when it doesn't have battery, if let's say suddenly server powered off, then the data is halfway written and it get corrupted. But when it has battery backed end, um, once the power is off, the battery will try to write the cache data into the disk itself. That's also the high performance, because it will use the disk cache instead of physical disk, uh, the tracks and the sectors. Another one is more adding more CPU, the system memory, creating multiple files, file groups, scattering into multiple physical disk, saving log and the data file into different disk, using table partitioning, and so on. It will improve the disk performance and it will resolve the disk bottleneck. Um, that's one of it. And the third one is the processor bottleneck. Processor bottleneck is something like, so far I didn't ask my clients to add on processor cores unless it's needed. I think one time it happened, which is really needed. We did the tuning after 1 year. It says that, okay, the SQL keep on prompting that um, thread pool thread pool wait type, CX consume, CX packet, and so on. Then they add on the CPU cores and everything settle. But again, before that, we did the tuning on indexing, database configuration, and so on. For 1 year, they used the same number of cores, but after 1 year, it couldn't make it anymore. So to resolve the processor bottleneck, again, we go for query tuning, workload tuning. We try to eliminate the unwanted recompilation for the queries. And we go for faster processor. We go for large L2, L3 cache. Um, we check whether the controllers, the drivers for the processor is up to date. And we try to stop unnecessary services and the softwares. By that one, we are reducing the uh, CPU utilization. But anyhow, you might ask that, let's say the database environment is having the latest version of the processor. The memory is sufficient, but you guys are still facing the processor bottleneck. The CPU is spiking. You check your workload. If your workload has a lot of cast convert built-in functions, if a lot of coalesce function, if it's using a lot of aggregations without proper indexing, and the table and the index is not sorted, then it will spike the CPU utilization. In the future part of this series of events, I'm gonna tell you why aggregation without proper indexing, it will spike out the CPU utilization. The reason is just the overview. I cannot wait for the part 3 to come. So the reason is when we go for the aggregation, the SQL needs to sort the data and try to do the stream aggregating. So when it tries to do the stream aggregating, it's quite fast. It will say that this is the value, then it will count it or sum it, then it put it inside the memory buffer. Then after that, it goes to another value and so on. But if it's not sorted, it needs to do, okay, it's huge number of records and it's not sorted table, then it needs to go for hash binary aggregation, which means it needs to hash all the values and try to do the comparison and try to do the aggregation. And that's hashing, it will consume the CPU resources. Yeah, so basically the CPU bottleneck, it comes all from the workload and the query. And the last one is the network bottleneck. Network bottleneck most likely never happen. But once it happens, it will kill the performance um, by 70–80%. I guarantee that. Once you have the network bottleneck, how to identify first? If you look at the query workload and the sys.dm exec request or sys.dm exec sessions, the last wait stats you see is the network async network IO. Async network IO means that SQL already prepared the data, the buffer is in the cache, the result set. And the SQL is dispatching the data to the client application. And dispatching, it takes long time. Okay? It has two reasons. Either the result set is huge. It is retrieving 1 million records. It's huge. That's why it becomes slow. Second, the network performance is having a problem. The network layer is having a problem, not the SQL, not the application. So how to identify if the network layer is having a problem? If you monitor the network TCP retransmit counter, and this retransmit is almost 50% of the transmitted packets. Means your network layer is not stable. And that is causing the TCP congestion window. So if you look at TCP congestion window, what happens when the packet moves from the server to the client, but the packet drop in between, get lost, okay? Then the server and the router windows and the windows in the client side and the server side, they will decide that, okay, instead of sending 8 packets at the same time, gonna send 4 packets at the same time. It will slash it into half. Then it will send 4 packets. If 4 packets also drop and needs to retransmit, it will slash it into half again. It becomes 2 packets. If 2 packets also drop, it will make it 1 packet. And that's the point. If you have network high retransmit uh, value in the counter and a lot of network packet drop, definitely you have these performance issues, and you as a developer, you cannot do anything. That is the network team responsibility to settle that. But if let's say we don't have uh, packet lost in between and this TCP contention uh, window, it never happened. You can add on the network adapters. You can team the network adapters. Teaming is very important because when you do the teaming, you can assign network adapter 1 to receive the data, network adapter 2 to send the data. And I suggest you can have a teaming in the odd number, which means that you can team for 3 or 5 network adapters, and you leave 1 as reserve. 1 as reserve means that if any of these network adapters fail, then the reserve will come in and carry on the workload. So you don't face any performance issues if one of your network adapters drop. And moderating and avoiding interruptions, which I explained, is the TCP packet drop. So any questions before we move to the demonstration? You can raise your question in the chat box. And data analyst or other SQL user kill performance with bad code. That's definitely. That is definitely. I have one of my client. They are having data analysis with using Excel and try to connect to the database using Excel, because when they try to connect using Excel generate the query select statement where there is no condition, there's no where clause, there's nothing, and select entire table, and the table was huge and caused a lot of blocking and performance issues. So what we had did it for that specific client, we actually trained their users. We trained them how to write a query and how to use that query inside Excel. Problem solved. Is by training your data analyst or other SQL users to how to write the query and what's the impact, then you can just simply avoid this problem. Because if you don't train your users, you cannot solve this issue. Honestly speaking, you need to train your users. So any other questions before we proceed? Okay. I have my test environment here. Are you guys able to see my test environment? Good. So first, I want to show you the performance monitor. Perfmon. Perfmon. Basically, we have two tools which is using the same icon. One is the resource monitor, one is the performance monitor. Today, we are going to use performance monitor. This tool is my favorite tool to do the analysis and the benchmarking. This is the live. You can see it like we can just add on the counters. So what counters basically we are looking for? Anyhow, as I said, this is the machine. If you have Active Directory account and you can access the other machines through the RPC and WMI, you are able to just choose the machine or browse it and monitor it. These are the objects: processor object, processor information, RAS and ports and so on. And we have all these SQL related objects as well. And another one is the counter. When you expand, this is the counter. Some counters, they don't have instance. Some they do. Like, let me show you, for example. Yeah, so this is the instances for all instance or total and so on. I want to monitor my CPU utilization, memory utilization, disk IO, and at the same time, I want to capture some benchmark related to the SQL database. So for the processor, again, what I mentioned here is just what I call it for this use case. For your own benchmarking, you need to choose relevant counters and the objects based on your environment. I can share with you later on through the document what sort of counters you need to choose as ideal benchmarking. So I want to get the physical disk activity. One is the average disk queue length. Is very important. If the disk queue length it increase more than 0, means you are having disk bottleneck, disk issue. If you see a lot of disk queue length in your database environment, like more than 10, 20, I have seen some of it 1000 plus, definitely the disk is the bottleneck. So this disk queue length is for both read and write. So in this case, I just want to choose for both read and write for total disk. Another one I want to have for split IO. Split IO means that when the request comes to the disk, whether the disk need to split it into 2, 3 IO to complete the entire IO and the transaction, or it's just one. So split IO is important as well. I'm gonna get for the processor CPU utilization, processor time for total. And the process as well. Processor time, but this round I want to use for, sorry, I want to use for SQL Server. SQL SRV. Okay, but this is SQL SRV. I don't know what process it is. Let me check it out. Details. This might be 0. Sorry, this one is 0, 1, 2. 0, 1, 2. Let me check 2. Okay, 2 must be 2017 instance. And another one is the page fault per second. I want to capture as well. Then let's go and capture some database related Matrix, memory manager. Was it in the memory manager? Stolen server memory. So stolen server memory means the buffer pool, it doesn't have sufficient capacity to keep the data files. It's actually stealing from the planned cache portion, because memory in the SQL Server, it has a lot of portions. So I'm gonna go for cache hit ratio. I'm gonna go for latches, number of super latches, latch wait time as well. I'm gonna use the buffer manager, buffer cache hit ratio, checkpoint, lazy writer. Yeah, for the time being is good. Yeah. So we have all these, basically the counters, and we can highlight it as well. Now, I want to run specific query. Select cast as big int ABS. Let me put it decimal 5 and ABS. Sorry, the ABS is, yep, cast, so it doesn't have, oh, sorry. Okay. You see, like, it was 30% drop, and it goes up. So you see, like, when I continuously running this query, goes higher. Okay. And when it runs continuously, it makes the CPU spike. So now just imagine if you have this query, this function, and it needs to run frequently in your database environment, then definitely it will spike up. So sometimes we need to avoid all this casting. So when it comes to the casting, we need to avoid it. How to avoid it? Either change the data type inside the table, or we create computed column and we change it inside the computed column. So let us try here. Cut, declare at num decimal 18, or set at num, or then at num. Okay, still shoot up because we still have variable here, and every time it needs to run. So just imagine this is it. Now I want to put it inside the while loop through, sorry, 1 equal 1, begin, end, and I try to run it. So still saying that the processor utilization is spiking up. So no matter how, wherever you put it, when it comes to the cast, convert, and those this kind of arithmetic functions, it will spike the CPU utilization. So this is the general, but I want to check. I'm not sure whether it's this instance or different instance. Let me try to copy and paste here and try to. Yeah, it seems like this is the buffer cache hit ratio, CPU, processor time. Yeah, must be different instance. And we use this. Oh, SSMS crashed. You see, like even we have disk I/O split I/O, average disk queue length, even though we don't really use the workload because this is the virtual machine, very low spec. So we still have it. Cache hit ratio, stolen memory we have, lazy writer we don't have, and processor time. And this is the page fault. So as I said, however you do, it will utilize the CPU. So try to avoid cast and convert inside the SQL. The best way is if you look at the data, the application architecture, you can push some of this cast and convert into the application. Like for example, if you want to get the ABS, just get it inside the application rather than the SQL itself. So this demonstration is more on the performance monitor and how to use it. Once you set all these counters, you are able to save the setting if you want to reuse it for different machine. As long as the counters, the names are the same, then you can use it for different machine, or you can use it in a web browser. Let's say the template setting, and I can just close it. Go to the documents, template setting, open, ask, and right click, yes, play. Then I can have it inside the web browser as well. This is good. Can you see historic data of how your query performed with this? No, we cannot see the historic data with the performance monitor unless you set as data collector, which I'm gonna share with you the tip in this demonstration. So once you settle this is alive. So this is how you can see it. But I want to share with you a trick that you can capture the database workload and the machine workload and mix it together. Um, the second thing that you can use is the SQL profiler. So SQL profiler tool is for profiling the database workload. Let me just put it here. Sample trace. Then we go for the standard default. We save it into a file. Let's say sample trace. Event selection. Show all the events. These are the events you can select what you want to have. Then batch starting, batch completed. Okay, perfect. Then we just run. This is query profiler. So every time that we run a query, it will trigger something here and it will show it. Like, for example, if I trigger here, then you see it shows the batch, but it doesn't show the statement because I didn't choose the statement. So every time that I run a batch, then it shows. Come out with the result. Let's say the duration, the CPU utilization, number of reads, writes, and so on. The problem with this SQL profiler tool is it takes a lot of resources, especially when the time that you want to sort it while you want to capture. So I don't suggest you to use this SQL profiler for long term and inside the same server. So if you want to use it from your laptop to monitor and trace the SQL instance remotely, you can use it for the short term, maybe half an hour, 1 hour, 2-3 hours maximum. But if you want to let it run for few days, few months, I don't suggest this. I suggest you to use either extended events or you use the SQL trace. So how to generate the SQL trace? I want to capture this as a SQL trace. I just pause it, go to the file, template, export SQL trace definition, and I go for SQL trace, this template, then SQL trace template script. Yes, then I close this guy. Then I want to open this SQL trace template script. You see, like here, it actually generates the script. Then we just need to change this as temp SQL trace. And the maximum file size I put, let's say 500 MB. Make sure that you have that path temp, so it's here. Okay, perfect. Then we execute it. Once you execute, it will give you the trace ID. Then from there, you are able to verify whether the F and trace get info trace ID 2. Yep. So you can see the definition and it's enabled and running. So if I run any kind of workload, it's basically capturing. You see that SQL trace here. Good. I have SQL trace and I want to have performance monitor as well. Performance monitor at the same time. I want to collect again for performance monitor for a long period of time. What I do, I just go for data collector set, new, and I want to look into, let's say, SQL perf. Then I choose manually the counters, performance counter. I add on some counters, for example, CPU utilization. I just want to go for CPU at the moment. Processor unit, all yes. And yeah, then the privilege time as well, for example. I make it every 3 seconds, taking the sample. Yep. Started now. Okay. Okay, this is up and running. Now it's running this batch. Because I select the batch statement, not the statement itself. So I need to stop and start it to make sure it captures. Okay. The next one is, let's say you want to merge both together to have a good view. You need to stop this guy. Then you need to stop your trace as well. It's 2. If I don't mistaken, 2 is the stop. Okay, sorry. Then it's 0 is the stop. Okay. It's already stopped. Yep. 2 means that it will delete it. So I have the trace as well. Okay, and that thing. So the next step is if you want to merge it, open the SQL profiler. Yeah, just connect. Then try to open the trace, sample trace, and you click on File, Import Performance Data. Then we look for performance data here. See, what was it? Perf log, admin, SQL perf. What I suspect is, okay, let me drop this guy. I don't need to drop. This guy, we started first. Let it start. Basically the data analysts, they cannot use these tools. These tools are related to the server and the performance. The data analysts, they cannot use it. But for the next topic, I'm gonna show you the technique that data analysts, they can see their specific query performance. Not by using this tool, it's by the query itself. So I just started this data collection. Let me start the trace as well. Then we try to run again. I'm just trying to simulate the environment. Okay. Then perhaps the first we need to stop this trace. Then we go and stop this guy. Then let's try to see. C temp SQL trace. Import data. Perf log admin. Okay, now it asks me which counter I want to have. Then I said, okay, the processor counter. Then I can choose, let's say, oh, I say that zoom out. Let's say this, what sort of query is running here, and what counter. Then I can find out, okay, this actually started from here, and this is the query, this is the batch that is running. So by this, you are able to find out what's the overall resource utilization related to the batch or the query that is running. It's very useful technique if you want to find out the problem. Okay. If you want to find it out, you just leave it run for a day or a week, then you can have a very beautiful chart. So you can find out which query and how much resources it's using. Any questions so far? No? Okay. So the next one is if you want to look at the DMVs for the query, and have it here. Let's say I want to look at the DMV for the queries that are running. Select asterisk from sys.dm underscore exec underscore request. So this one, it shows all the requests, including the system request and the wait type, the blocking, the progress, everything here. And it shows my own session 55, 55. So if let's say I run this one and I run this again for the 53. So it shows that 53 is the select statement is suspended and so on, but it's waiting for network IO sync because the results are still waiting. And how long it wait is about 1.6 seconds is waiting. It doesn't cause any blocking, elapsed time, and so on. It's all here. If let's say you want to find out what is the query plan for this specific query that is running and is consuming a lot of CPU, you can just do the cross apply with sys.dm exec query plan is the function r dot plan handle and q. Then let's go for q dot query plan and r dots. So it shows that, okay, this query is at the moment is running. It has a query plan. Let's see what is it. It says that, okay, this is the query plan. It's just the while loop, select without query. By this query, you can find out which query is running and what's the query plan. And if you want to find out what is the query that is running, you can again cross apply sys.dm exec SQL text, then r.sql handle, then t. And you go for t.text. Then it come out with the query itself, the batch. Okay. So let me show you another kind of DM select asterisk from. Now you realize that it's getting slow because of this query and the CPU utilization. My SSMS is getting slow. So what I need to do, the best is to just kill the session 53 to release the resources. Okay. Yep, it's already killed. So the next one is I want to show you is a sys.dm underscore os wait stats. This one usually you need to do order by wait time ms descending. Then it shows all the weight statistics within the SQL database engine. The top 10 is very important. If within the top 10 you see page IO latch, CX packet, CX consume, thread pool, lazy writer underscore sleep, um, checkpoint queue, checkpoint, and all these critical things, which I'm going to share with you in the document, then those are the bottlenecks. And it can be related to the disk, to the CPU, to the memory, and so on. So this is very important to check frequently. Yeah. And if you want to look at how much memory utilized by the what I call it, the query is the query memory grants. If you run this in your production environment, you will see all the queries that how much memory is used, granted, what's the query cost, and so on. It will appear here. And this is very good start for you to tune your workload, the database workload. This is the best, perfect starting point. Um, so if there's no question, then we go for 5 minutes break. Okay, so the next is SQL query performance analysis. Previously was the system performance analysis. So we use the um, performance monitor tool. We use some DMVs to just monitor and see, and the SQL profiler to see how's the overall system performance. So in this topic, we are going to use some specific DMVs, and we are going to run few queries that is problematic again and find out what's the problem. SQL Server Profiler tool is a tool to capture the trace. It's actually tracing. So as I said, I suggest that you run it for the short-term period. You choose less events, less columns, less records to capture, and it has performance impact because of the GUI. Try to not sort the result while it's capturing, because it will consume a lot of resources on the server. And if it's possible, if you want to use it for long period of time, it's better to use SQL Trace. Okay, this is about the SQL Profiler. SQL Profiler basically is very old tool, because recently you can use after SQL 2012. Anyhow, SQL 2008 R2, it had extended event, but it wasn't that developed and enhanced. But in 2012, they released the extended events to replace the SQL Profiler. And also Microsoft has, provided one DMV called sys.dm underscore os underscore buffer ring. And that's the buffer ring within the engine. It can gives you a lot of insights like CPU utilization for the SQL process, the instance, and so on. But anyhow, for the beginning and the beginners, SQL Trace is easy. SQL Profiler also is easy to use. Yeah, as I mentioned and explained to you just earlier how to use it. Now we need to look at the query performance. Always remember, not every query they are problematic by running one time off. For example, you remember just now I wrote a query like casting and getting the ABS, calling ABS function and the cast function. If you run it one time, it's not problematic. It doesn't have any impact. But if you put it in a loop and run it frequently, it becomes problematic. So basically we have two types of queries, or I can say two categories. One is single execution, which one time you run, there's no impact. But another one is the multiple execution. If you execute it multiple times continuously, then you will see the problem and you will see the impact on the hardware resources, and it will cause the bottleneck. Basically, in this topic, we are going to learn how to identify whether the query is single execution or multiple execution problematic queries. If it's single execution, by just creating the index or perhaps doing some configuration, you might resolve that. Or you may not even need that to resolve it. You just leave it as it is. And another side, which is the multiple execution problematic queries, that one definitely you need to fix it and resolve the problem. To identify this, you need to use a DMV. There's no way to use profiler or extended events and so on. It becomes very, very challenging for you to find it. With DMV, it's very easy, and you can see it in real time, whether that specific query is causing problem, changes you have done, whether it improved the performance or not. So to identify the slow running queries, the best is to capture the execution time, to monitor it, to analyze the execution plan. You look for the operators within the execution plan, which in the next part of this series of session, I'm going to teach you how to read the execution plan and how to resolve the bottlenecks within the execution plan. So to identifying the slow running queries, we need to use a DMV, and we need to check the wait stats. We need to check the elapsed time for each query and the plan, and the resource utilization. Can say that. When it comes to the slow running queries, when we try to tune this type of queries, we actually need to balance the both elapsed time and the resource utilization. Sometimes business users, they say that, okay, I want you guys to improve the query performance by 90%. But if you try to improve it by 90%, you are going to use 50% of resources while that query is going to be executed, which means you are going to get more resources to reduce the elapsed time. More resources to reduce the elapsed time. But in other hand, some queries, they are using more resources at the same time they are having high elapsed time. And once you do the tuning, you need to always focus. You want to reduce elapsed time or the resources utilization. Those queries that their elapsed time is high and the resources are utilization is high, I suggest you focus on the resources. You reduce the resource utilization. If you can keep the elapsed time same as it is, it's good because you already improve it. You already tune the query. You reduce the resource utilization with the same elapsed time. Still, you are in the winning side. But if you, let's say, reduce the resource utilization and you increase the elapsed time, no, you are not in the winning side. So you need to revert back. This is the trick and the technique that I learned over the years. Not every time query need to run fast. Sometimes it needs to run slow and at the same time use less resources to allow other queries and the workload to carry on. Otherwise, it will cause a lot of blocking, bottlenecks, and so on. Identifying the costly operators in plan cache. Once we gather the plan cache, once we identify the long running queries and we gather the plan cache, we need to identify which part of plan cache is causing the trouble, isn't it? We need to know how to read that plan cache. Plan cache is like a map, so you need to know how to read it. You need to know what's the difference between index scan, index seek. What's the difference between RID lookup, VLOOKUP? What's the difference between, for example, hash match operator with the stream aggregator operator? Or what's the eager type of operators and so on. Once you understand all of this, then you can find out, oh, how to tune this. Instead of index scan, you change it to index seek, then it runs faster. Or if it's index seek in certain queries, you change it to the index scan, it runs faster. Because we need to understand what each operator does and what's the impact, and whether it's suitable to the workload and the query or not. First of all, we need to focus on the nodes in the execution plan and the relative cost. More on the statements, the operators. Then after that, we look at the thickness of the connections, the arrows. In the execution plan, it shows that how many records and how much data is carry on from one operator to another operator. If let's say you are having, for example, index scan 100 MB or 1 million records move to the filter operator. After filter operator, 100 records move to the sort operator, and then it's sorted and so on. Then this execution plan, it can be tuned. We can make it as an index seek. It can eliminate the filter. It can eliminate this sort option, sort operator as well. And we can improve the performance. So we need to learn all of this. Let's say how to eliminate the bookmark and so on. So execution plan, as I mentioned to you, is the map for SQL Server to execute the query and retrieve the data. We have two type of execution plan. One is estimated, not two type. How we can gather it is two ways. One is actual execution plan, which we can get it immediately or during the real time of queries executing, or estimated execution plan, which means that query is executed and we capture the last execution plan, which is estimated. It might not be the accurate and the actual. So let me show you the execution plan cache analysis here. Then can dismiss them. Let me connect to one server that I have a database. Yes, I have AdventureWorks database. Okay. So I want to type a query, select asterisk from sales order header. Page. Inner join sales order detail E and D dot sales order ID equal H dot sales order ID. So what this query returns is the sales order header and the details together. Correct? Then I put where if the shipment, if ship date is equal this. It's going to return 174. I want to capture the elapsed time. So set statistics IO time on. So I can see here. Okay, it says that it scanned the table 65 times and logical read, and the logical reads here. There's no physical read, and it took 127 milliseconds. Okay. And this is it. This is the asterisk. So let me capture the actual execution plan by just right clicking. So this is the actual execution plan. What it says that it's scanning the entire sales order header and is seeking for sales order detail, and it goes to the compute scalar and nested loop inner join, then it come out with the result. So the bottleneck here is the usage is 71%, is belongs to this sales order header scan. Why? We put the prediction, which is the ship date here. But it's actually scanning because the ship date column doesn't have any index. So what can we do? Even the SQL optimizer already recommended the shipment date. So let me create one index. IX01 on sales order header ship date. And I make it ascending. So then I run it one more time. Now it become index sick, but the problem is I have key lookup. I make the situation worse. Okay. And I have key lookup here, and I have clustered index seek here, which is remain the same. So now I need to get rid of key lookup. How should I get rid of key lookup? The problem here is this guy. When it comes with asterisk, means it will retrieve all the columns from both tables. But my what do you call it, the where close criteria, the filter criteria is based on the ship date. So it used my index here to find the date and the RID and the key lookup, and it performs the key lookup based on whatever it finds here. That's why we have one nested loop join here as well. So how to resolve this? I need to limit my columns. I cannot say that I want to have all the columns asterisk. So I'm going to use h.sales order ID, h.sales order number, h.subtotal, d dot um, perhaps product ID, for example. Then let's run again. Execution plan changed, obviously, because the query is changed. Now I have index seek, but again key lookup and index seek here. So how to get rid of this now? The index which is in the upper hand, which means this one. Okay, when you look at the table, it's the same. Sales order header, sales order header. I need to move whatever column that is considered as output list here and the predicates into this index here. So what I have here, when I look at the properties, when I look at the output, I have subtotal. So I need to make sure the subtotal is inside this index. I don't want it to be out of the index. And the predicates as well, because again, with the predicates, it's, it has predicates here, it's joining. So I need these columns as well. So I need the sales order ID too. So what happened? Ship date is a filter. Then I make include what column is the sales order ID and subtotal with drop existing on, and we try again. We get rid of RID lookup. Performance wise, it's faster here. It's only 2 reads. Elapsed time reduce. Not much. Of course, it's not sensible. You cannot sense it. It's in milliseconds. But we can see the improvement, about 30% improve in terms of elapsed time, and a lot of reads reduce. But do you see another problem here? Yeah, I can see here. 65 times it been scanned. Okay. How can we resolve this guy? Can we do something on this? Yep. Basically, we can create another index, but we need to give a try first on sales order detail based on the sales order ID include product ID. Now we reduce the logical rates 157. Okay. Execution plan is using our new index. Can I improve it furthermore? We want to check the price and the effort and the benefit, correct? I can do that. What we can do is yeah, we do this one. We have this guy here. We put it where ship date. So this is filtered covering index, which means if there's any query that the filter it match with this value and the filtering, it will use this index. So it's actually used for specific queries, which means that this query sorry. Why is it okay? I don't know why it throw an error, but let me try. Okay. Error creating window handle. Okay. Why? Perhaps that I need to drop it. Let me drop this first. Is the SQL error now? Correct. It's off. Oh, SSMS crashed. Okay. My test environment is faulty. Let me try again. Okay. Okay, now it's created, including the where clause, and select. So you can see that it's using this index. The improvement is not much. Actually, there's no more improvement. So you can see that the most that we get is from the first index that we create. That's the most. The second and the third index which we create, it doesn't make any impact, which means this index, this guy, will include where clause. It has no difference than without where clause. And this index totally didn't do any it didn't do any improvement. It didn't help us much. We can just drop it. So this is the process of doing the tuning. So every time you need to check, trace it, track it, and make sure that everything is okay. So now I want to perform some aggregation. Let us remove this guy. I think is see that line total, I think is good. I want to get the total sales for specific product. I want to just do the aggregation and I want to see that sum line total as line total. Paste it here. This is something that probably we get. Okay, this shipment date also we don't have it. So I want to see product ID is valid. Oh yeah, It needs to be grouped by d dot product ID. So we have the number of logical reads, 1247, one-time scan. You can see that is the index scan, then the scalar, compute scalar, then the hash match aggregate. It's not the stream aggregate. Means that the data that it retrieve is not sorted and is huge number of records. Okay, then it come out with the result. How to improve this, the performance? We need to make sure the sorting and the hash match aggregation, it doesn't happen. So what we do, we create index var ix04, for example, on sales order detail. Then we go for the product ID and line total ascending. You see like logical read slash into half. Elapsed time slightly lower. It was 155 millisecond. Now it's about 20 millisecond. But the resource utilization slash into half. And instead of hash aggregation, we have stream aggregation. Stream aggregation, it doesn't utilize CPU. It just check and what do you call it? It just combine and so on. So this is the way you can do the tuning. Like for example, most probably you will have a query for, let me copy again. Paste. Maximum sell, the last sales date. That modified date, for example, as sales date. You can see that 1247. We have scan directly goes to the hash match and the result. So how should we solve this? We can create index var ix05 on sales order detail. Again, product ID ascending. And here we have this modified date descending. .398 stream aggregation and the index scan here. Why did I move this one to descending? Because I want to get the maximum modified date for the specific product. So it will be like, for example, here, it will be product one, the maximum date, for example, I just put number 10. Product 1, comma 9. Product 1, 1, comma 8, and so on. So when it comes to, for example, product 2, 15, product 2, let's say 14, when the SQL comes to the scanning, it will read this guy. It says that, okay, it's based on descending. So the first record that it reads definitely is the maximum. So it will read this one. Then it jump to the next one, read this one, and so on based on the key. It runs faster. If I change this one to ascending, you might see some sort operation. No, SQL optimizer reverse it, so it read from the back. Let me check for you. Is the reversal? No, still use the forward, not the reversal. Still use the forward. But anyhow, because it's indexed and sorted, it's using the stream aggregation. Any questions? So now let's look at the long running queries. sys.dm exec query stats. This DMV, it will tell you that what query, when was the last execution, how many times it executed, what's the total and average and so on elapsed time. So you can see that here it says that total CPU time, last CPU time minimum, and the maximum CPU times, how many times it executed. Let's say like logical reads, logical writes, total elapsed time. Um, remember, logical reads is from the memory. If it says that total read write means it's the physical from the disk. Total elapsed time, last elapsed time, maximum, and so on. You have all of this. Like for example, how to identify the long running queries simply by order by total elapsed time descending and the total, the last rows ascending. By this, you can find a query that return only one record, but it takes very long time. That is definitely long running query for one single record. From there, you are able to find the SQL handle and the plan cache. How to get these things? You can cross apply with sys.dm exec query plan, which is the DMF, s.plan handle q. And another one is the cross apply sys.dm exec SQL text, which is s.SQL handle t. I want to bring this guys forward query plan t.text s.text. So now I can see that, oh, this guy is considered long running queries. The CPU time, logical reads, you can see is the high. So you can sort it by logical read as well. It depends what type of query you want to look. You want to look for the elapsed time, long running queries, or you want to look for the queries that consuming a lot of resources like memory, CPU. From there, you can just do the sorting, then find out the long running. And here, like for example, this guy is considered long running, number 2. And this is, but this is the system, so we are not able to change it. But anyhow, for this one, once you click, oh, you can see that here is the select asterisk inner join. It's 2 scans. How can you resolve this? It's a merge join. It's supposed to be nested loop join, not the merge join. Merge join is quite costly compared to nested loop. So how can you solve this index scan and index scan? Are we able to solve it? Yes, we are. So let's grab the query. This is the query. Let me choose the adventure works. We go for, oh, no. We go for actual execution plan. This is it. First of all, we need to limit our result set. First rule, what query would you like to have? Account number, comment, for example, order dates, subtotal, count of D dots, product ID, as and here we group by D dot product ID. Sorry, not H dot account number, H dot comment is not needed. Perhaps we go for other things, order dates and H dot subtotal. We run. Scan, still we are having hash match and so on. Then we need to create index var ix09 on sales dot. First one, we look for header, sales order header on sales order ID. Then we go for account number, order date. Okay, it didn't change anything. Just goes by, again, the previous query. Let me try to recompile it. Still goes by same as the previous query. So let's try again. Include with drop existing on. So you see that the tuning has a lot of step forward and backward. Still remain the same. So if let's say let us see that whether we can influence it with index part ix09. I don't suggest this, but let us try and see. Okay, with index, it says that it's scanned, but it has key lookup. So what is the key lookup? Is the subtotal for it and the sales order header. Yeah, so that's why it didn't have. So we didn't have the subtotal. We need to have here subtotal run. Yep, now it's using our index, which is non-clustered index, cheaper compared to clustered index. And this is also non-clustered index. Then we have merge join, inner join. Then we have hash match here. So how to resolve this is we need to go by try to redoing this by adding this into the columns, and we see how's the impact. So account ID first is the were close, then the account ID, then the order date, then the subtotal. And let's rebuild it. We retry. Okay, still remain the same. We have the hash match here. Then we need to create another index file ix10 on sales order detail. Then we need to look for sales order ID. Then after that, we have product ID. Then we create sales order ID, sales order ID, and try to recompile. Not much different. We have this group by. We have sales order there here, product count. Okay, product count, then we have all of this. Yeah. So the most that we can tune is come up to here. We cannot go further unless we change the query. Then once we change the query, then it will be different. For example, let us try to change it this way. Copy. I get this guy as product from with CTE as okay. This is the scan merge goes here. Let us try. And here we have account number, order date, subtotal, count, product ID, then group by. No, still goes back. So this is the optimum query performance and execution plan you can get for this specific query. Any questions so far? Okay. There is no further question. Then you can scan this QR code. We are providing the complimentary services to whoever attend our event. You guys can have up to 5 SQL instance health check with documentation. So we can tell you what's the problem, what you need to do, including the script. We can provide you the advisory service. Like let's say you have project or you have some migration moving to the cloud and you want to get some advisory service, we can provide that as well. And also if let's say you want to know about our product AIDBA, we can have one-to-one session and present the product to you. So the product is capable to do all these tunings and all these hassles that I show you. It's able to do it by itself. Yep. Thank you. So anyhow, you still have questions, please put in the chat box, then I can answer you. You're most welcome. Thank you guys for your time and your patience.